I will explain about CMOS inverter design using Microwind or DSCH. So we know that CMOS inverter having one NMOS required, one PMOS transistor required, and this is the input and output. So while giving 0 we'll get 1 output, while giving 1 we'll get 0 output, as we know that. So to design this circuit we are going for, that is DSCH, and for mask layout or backend we need to go for, that is the tool is, that is Microwind. So first we need to open the DSCH. So open that. This is the DSCH 3.9. Need to open to design a CMOS inverter. Here right side that is symbols are there, symbols library. From this only, for any circuit to design, here the symbols are available. We need to take, and we can take and design the circuit. And coming to here in the top side, you can see this here. So this is the simulation part, and this is the timing diagram. So, and wire connection is there. This is the wire connection. If you want to give the connections, we need to use this. And if you want to move, we can move by using this symbol. If you want to delete, and here gun symbol is there, using that we can delete. So for that, first open the DSCH, then we need to go for file and select foundry and select the 45 nanometer technology. We can use any technology, but I am using right now, that is 45 nanometer technology. So then click on that and then open. Then for to design CMOS inverter, as I said, that is one NMOS is required and one CMOS transistors are required. So all the required transistors need to take, and one supply, of course supply is required, and here transistor, PMOS transistor, and this is the ground, and this is the supply. And then we need to take, that is input is this one, input button, and this is the output button I am taking, that is LED. Then we need to go for connections. To give the connections we are going for, so this is the timing run simulation, and these are the different options to design, to take required option. Now I want to go for, that is connection, that is wire option. Click on that. Then we need to start the connections, and two gates are interconnected, and source and drains are interconnected in the diagram, and output across that we are taking output, and supply need to give, and input across the two gates we are giving the input, and give the inputs. And if you want to delete, we can delete using gun symbol, and again I am click on wire and giving, that is input, and here also need to give the connections. So then the circuit connection is completed now, circuit completed now. Then we need to run. For that here there is a simulation option is there, run option. So we need to go for, you need to click on that. So I am clicking on that, and then you can see this, while giving 0 we are getting output 1, while giving 1 we need to get, while giving 1 we are getting 0 output. Similarly we can check it, input outputs. So then after that, here there is a timing options, timing diagram option is there. So click on this. Here you can see this, this is the timing diagram. So we need to click on that, and here you will get, we can see this. So while giving 1, 0 output, while giving 0, 1 output, 1, 0, 0, 1, like this will get the timing diagram options. So then we need to close it, and then we can go for, we can extract the truth table also by using DSCH 3.9. For that there is a option simulate, then click on simulate option, then go for truth table and extract logic simulation, and extract the truth table. Click on that and we'll get this is 0 while giving 0, 1 output, while giving 1, 0 output. So like this we can get the truth table also, and so that is the truth table, and close it. Then this is the main option. We need to save it. Go for file, save as, and I am saving the documents RR. Across the documents I am saving as RR, and in Raju sir file I am taking as that is RR. Then again this is also one more important step, that is go to file and convert it into Verilog file. This is the main step. Verilog file converted as a Verilog file. This is the main important step. Make it as a Verilog file. Don't forget this. This is the main important step. Update Verilog, then click on OK. So this is the front-end designing process. Then we need to design mask layout diagram. So just minimize it, and then we need to go for Microwind. Open the Microwind. Again need to open Microwind tool. Go for Microwind tool, and click on OK. Then again we need to go for that is file and select foundry again. 45 nanometer, as you know that in the 45 nanometer technology we are using. So then here go for simulate option. So this is compile option. Go for compile option and compile Verilog file. Then we need to, whatever the file we are saved, that we need to open here. So go for documents in that Raju sir file. Open our required RR file, as I have saved already as a RR. Then open. Then you'll open the window like this. Then we need to compile. So need to get 0 errors. So here if there is any errors we'll get. So otherwise we can get it as a 0 errors. Then back to editor. Click on back to editor. So this is the supply, and this is the ground, that is blue is used for a metal and red is for polysilicon, and these are the contact cuts, as you know that. And here you can see this input and outputs are there, and this is the mask layout diagram for the mask layout for NMOS inverter. So this is the final step, but of course if you want to see the 3D diagram, here there is a option is there, you can see this 3D. So here by clicking on that we can see the 3D diagram for the CMOS inverter. So this is the CMOS inverter diagram, and if you want layer wise you can see that. If you click on diffusion, diffusion layer will get it or removed. If you click on metal will remove. So whatever the metal, whatever the diffusion you need to observe, you can click on that and it will be appear, of course. And then 3D view completed, then you can go for step by step. For that, here there is option process steps in 3D. Click on that, and there what are the steps going on this to design a CMOS inverter. Will observe here, you can see this is the diffusion. Then we can see this, that is thin oxide growth in the third step. Then thin oxide interconnection with high speed. Then gate deposit, how to deposit a gate. Then create contact cuts, those are the contact cuts. Then VDD holes and filling. So like this we can see this step by step fabrication process to design a CMOS inverter. So like this we can observe that. So, and this is the final CMOS backend, that is MOS layout diagram for the CMOS inverter. And so this is the, so as you know that in the first step we have designed that is CMOS inverter using DSCH. Then we are opened, that is Microwind, and to get the MOS layout diagram. Thank you.